The next speaker is Claudio Jeker, who is still a long-time OpenBSD developer and will still currently talk to you today about OpenBGPD.
Yes.
So, join me in welcoming Claudio, please. Thank you.
Thanks. So yes, I will talk about OpenBGPD. The title is Gotta Go Fast. One of the issues of OpenBGPD is that it is not as fast as it should be. And I will present a little bit where we are and where we're going. And I will start here with more or less like a start on the past. OpenBGPD started in 2003. That's 15 years ago. That's quite a long time. I started to go back in memory, like what was going on in 2003. So yeah, I started with OpenBGPD, mostly out of frustration with, at that moment, the only other kind of open source solution for BGP, which was Zebra. It had various issues and instability because of that. So this is when Henning, who was also a Zebra user, and I kind of both out of frustration just said like, oh, okay, we need to change something. Maybe also for people to remember 2003, the internet was a lot smaller. We had just reached around 125,000 prefixes. The first CAM tables were starting to run out of prefixes and people were starting to freak out. At that time, I think internet exchange points started to really grow. They were popping up a little bit everywhere. And it was mostly kind of trust-based. Like everybody was trusting each other to do the right thing in the internet. So it was fun times. OpenBGPD already at the beginning, it was always a little bit about internet exchange points and especially the route servers used at internet exchange points as an idea of what can I do to make an operator's life easier. So some of the things that we did is we actually added some special features to make life easier for people. So there was the idea of neighbor templates, using templating as a way of configuration, using special kind of macros to make your filters in a way that they're generic. So you don't have to add special filter blocks for each and every peering that you add. And so because of that, it was kind of possible to run route servers with very little administrative maintenance tasks. Like you set them up and they were running and everything was fine and everything was good. And a lot of people started actually using that, especially like the smaller internet exchange points, because for them, having to reconfigure the root servers was always like one of the tasks that people just did as a hobby, and it normally took way too long until like a session came up and things like that. Now, let's move forward a little bit. So let's have a look at how it looks now in 2018. So in 2018, OpenBGPD, now 15 years old, is a very solid base. It has all the important protocol features that you need for running BGP. The basic design did not really change. The RIB and the filters have not changed since the beginning. And that starts to be a little bit of an issue, especially when we start looking at the internet now, where we have now 750,000 routes in the DFZ. We also have the problem that the trust model is no longer working. Like there have been so many misconfigurations or sometimes even really hijacks of networks that everybody is now like, yeah, we need to start doing filtering. Especially at the internet exchange points, filtering is really important because it has been shown that a lot of the hijacks or the takeovers happened through internet exchange points or peering sessions. So there it's a point where we actually need to work on. Now, how does it look with OpenBGPs and especially at these route servers? Now, the problem there is, and this is why we're not fast enough, is that running a route server with OpenBGPD and full filters is too slow. This is because of the old RIB design. There is some problems, like one of them is, as an example here, if you reload the configuration, the soft reconfiguration happens as a front end, a foreground task. It blocks everything until it's finished, and so if that takes a long time, then you're kind of not getting updates and withdrawals through the system for a reasonably long time. Now, as an example, at a small internet exchange point, I'm using here YYCIX. This is a Calgary internet exchange, which is actually running OpenBGPD with full filters generated with a route server, a tool to actually generate these configurations. So using their configuration, we see that they're actually generating 370,000 filter rules to do the filtering. And this is way too much. And the config reload on their system shows that it sometimes takes up to an hour to actually finish. And that is way too slow. And one of the big results of this is also that most internet exchange points, because they don't really have another choice, started to using BERT for everything. So almost all the internet exchange points that actually do filtering run BERT. And as people know, a big monoculture is normally a bad thing. So one of the so people were actually coming to me, especially like somebody like Job Snyder's, and we're like, hey, we need to have OpenBGPD back on speed. We need to do something here. We need to get an alternative again, so that people have actually a choice. So yeah, this is a major effort, and as I said, like Job came to me in 2017 and was like, hey, if I would bring you money, would you actually work on OpenBGPD for like full time? Would you quit your job and just do open source? And I was like, after about 15 seconds, I was like, yeah, sure. This is. So he went out and actually got the money. So we solved the issue thanks to the RIPE Community Project Fund and a lot of the internet exchange points who also chipped in, one of them being NetNod, but there is also like a lot of other smaller ones, bigger ones, all kind of giving a little bit of money. And with that, I'm now able to actually work full-time on OpenBGPD. So I really started working on this in June. One of the reasons a bit for that is that I had to terminate my old work contract, and my termination period was fairly long. So it took a little bit for me to actually really start working on it. But I still think that in the last 4 months, we did already kind of a major jump. So the good thing is OpenBSD 6.4 is actually being now more or less tagged and starting to be finished up. So we're soon going to have a new release. And let's have a little bit of a sneak peek at what we actually have on the OpenBGPD side in 6.4. The number one feature that I had at the top, we're now doing RFC 8212 compliance or fully compliance. We now have a default deny policy. So this is important for people who are actually running at the moment OpenBGPD and plan to update. You need to be careful when you update. The change of the filter policy requires you to actually touch your config. I tell everybody, change your config first. Like you can already build a default deny policy by adding a deny rule at the top of your rule set, and then make it work on 6.3, and then you can kind of upgrade to 6.4 kind of easily. The other big point that we added is RPKI ROA support. I think this is one of the big things that was missing, and we're currently not doing the RTR protocol, but we have a way similar to like older birds to use RPKI data. The other thing was we tried to, or I looked a lot at the configuration that was generated by tools that are out there, like a route server or a BGPQ3 that you use to do your IRR-based filters, and looked at what do we need to do to actually make them faster. So one thing that I introduced is what I call sets. These sets can be used for prefixes, for AS numbers, or for origins, which is more or less what the ROA support is needing. So a combination of a prefix plus a source AS. And with these, you can actually replace a large part of these filters with more or less one single fast lookup. We also tackled the software configuration issue. We now have software configuration running in background. So this means that now in 6.4, if you do a config reload, the system will still process all the withdrawals and updates that are coming in, and is no longer waiting until the software configuration is finished. All in all, I did a check. That was a few days ago. I think there is a few more commits that went in. We're currently at around 155 commits that we did since 6.3. I looked at the whole commit history of BGPD. This is about 8% of all the commits that happened to that project. I think this shows that this initiative is actually working. Like we're really picked up again on making a lot of changes to it and actually bringing it forward. Let's have a look a little bit at these big things a little bit more concrete. So for the RPKI ROA validations, what we have is like we have a ROA set where you have the usual things, like you can define the prefix, the max len, the source AS. You can use source AS 0 as it is in the RFC to kind of have a blocking entry. And we had, for the filtering language, we introduced what we called OVS for our origin validation state. And the OVS can be one of valid, invalid, or not found, as there is with the typical ROA lookups. And with this, you can actually write very quickly a rule to deny everything that's invalid, especially from your eBGP feeds. We also added BGP CTL support so that you actually can see how the state of your origin validation state is. So first of all, we show it, and also you can query it. And I'm running this on some of my border routers now, testing it. And I looked at it, and I was actually very impressed. Like I'm reloading the table more or less once an hour, and it takes just like 2 seconds to actually finish. So it's really quickly to actually update it. So it is possible to use like even this kind of static configuration and be very quick at working on it. Then Prefix-sets is another thing that we added. This is something that especially is used for IRR-based filtering. So you kind of define all the prefixes that somebody is allowed to use or send towards you. Here, this is one of my usage cases. I'm filtering 6939 Hurricane based on their IRR set. This is a huge table. This is not just these 3 entries. And here again, what I can do is I can go and say like, oh, if it's coming from this AS, I'm filtering it against this prefix set, and if it matches, I can set my community and say like, okay, this is now a trusted thing, and I can later on based on these communities then do decisions. The prefix lengths can be specified like here as a range, or you can also use or longer to just say like everything. You can use something like max len, as we saw beforehand in the ROA set. So there is a lot of ways of actually specifying these filters. And you can also use, like if you actually don't have any kind of prefix len settings in there, then you can also move the or longer outside and just say like, I have my networks in a prefix set, so all my announcements, and I can go and say like, deny from eBGP my networks or longer. Like if somebody's sending anything that should be mine, I don't take it. So that's prefix sets. AS sets, very similar, kind of an array of AS numbers that you can use. It looks quite similar. You can use these tables with the source AS, which is the rightmost AS number of an AS path, or you can also use it with the transit AS, so it's everything that's in between, but not the rightmost, or even the source AS. So you can do a little bit of a combination. I think the normal use case is source AS. And again, it allows you to match against it, set your communities, and use that the community information later on to change your behavior, or like maybe even deny some prefixes because of that. Origin sets, they're a little bit of a special case. We have one that's kind of the ROA set, which is special. The ROA set is always applied and it's always running. So and it updates the validation state of the prefixes. Origin sets are not doing that. The idea behind that is that there is some other databases that you can use. As an example, the ARIN Whois database has some information that you can extract. There is a few other ones where you can get data out. And what you can do then, because you actually have the origin, so the source AS, and the prefix, you're able to combine that with the IRR AS number set and go like, yeah, if your IRR prefix list for some reason is not really up to date, we still accept it through one of these other tables, and are able to go and say like, okay, this is still fine. We're trust this because we know that it is actually in one of these other tables. This is one of the features that a route server is using to kind of increase the scope of the IRR filtering, because there is cases where people, especially in the ARIN range, have issues to really update their IRR data. Now, let's have a look at the results. So, since I have the configuration for YYCIX, I was playing around with that one. It's using a software called a route server to generate root server configuration. It's actually a good tool because you kind of have a config file where you define all your neighbors, and it does all the magic is kind of hidden from you. As I said, the original rule set files in 6.3 were these 370,000 filters. And now in 6.4, thanks to the use of AS sets, prefix sets, and origin sets, we were able to actually get that below 6,000. So this is a huge drop in number of rules, and this actually means that the system is now a lot faster at working with the rule set, because it no longer has to go through all these other filter rules. Even with ignoring some of them, it's still way too many rules that you had to look at, and so the speed is now at a level where we are able to actually start working. The big part is actually the IRR-based filtering. If we look at it a little bit more closer, so from the 370,000 rules, almost 300,000 were just IRR-based filtering. And then the RPKI and the RNDB that were also loaded into that config more or less did the other 90,000 rules, and so just these features allow to actually make the config a lot smaller and a lot better. It also is good that we now have the background software configuration, even with the large rule set, where it really takes a long time to do the reload. It is no longer a big issue because the updates are still being processed. The withdrawals are still being processed. So it's not like something is sticky for way too long. It more or less propagates in reasonable time. So this is a good result, I think, for something that we just managed to do in roughly half a year of working on this. Now, this was the first half year, so there is another half year. What is the future? What will the future look like? How will it look in OpenBSD 6.5? This is due in May, so it's more or less like the other 6 months. My big topics at the moment are, first of all, better community filtering. I started by looking at all these filter rules and how everything is working. I started to realize that we have there a bit of a deficit. There is one issue is like, at the moment, the filter language only kind of allows you to match against a single community. There is some hacks around it by using like a community plus an extended community or something like this to kind of be able to use multiple communities to filter at a time. And this needs to be fixed. I also realized that especially software like a route server is using a lot of like setting and deletion of communities all over the time, all the time. And this is actually a fairly heavy operation, as it has shown in some of the profilings. And so it's important that we actually make that faster as well. So that is one part. There will be more filter changes, making them faster, tuning them, getting more out of them. Another big part of work is the RIB in itself. So the big database. There are still certain operations happening on the RIB that are just too heavy or too big. And by bringing more or less new ideas into this old design, we're able to, or at least that's my goal, is actually to make it go faster again, especially when it comes to like multiple RIB support, which is one of the things that a lot of the Internet Exchange Point route server providers are actually like looking into. Like they want to be able to have multiple RIBs so that every peer has its own view. Another important, or last but not least, for sure, is actually bringing back the portable version. There was a portable version at the beginning, and it was never really I would say at the beginning it was a little bit of a serious effort, but then we just didn't have time anymore, so it kind of got stuck at one point. And this needs to be changed. Like, we want to bring it back. We want to keep it alive, so that it is similar to like OpenSSH or LibreSSL as a side project of OpenBSD that is available for people so that they can run OpenBGPD not only on OpenBSD but also on other operating systems. At the beginning, there will be no FIP support, so you will not be able to actually export the routes into the kernel so that the kernel can do the forwarding for you. This is mainly because at the beginning, I'm really targeting for the route server setup, and there you don't really need to forward traffic, so that's fine. That screen went off. So then, how does it look after these 6 months? There is still a lot of ideas going around. there is work that I would like to do. So we want to work on multi-threaded support to make the RD even faster, especially kind of getting the filtering even using more of the cores of modern systems. And we want to add the FIP support to the portable version, and then for sure adding new protocol features. The ones that currently are a little bit on the short list is for sure AddPath, is BGP multipath, is BMP, so that we can actually do, or that you can plug it into your regular monitoring, and RTR support. Good. I want to thank, or a big thank goes to all these companies that actually make this possible. NetNod, RIPE NCC through their community project fund, all the other internet exchange points who actually jumped in and made it happen. And also a big thanks goes to Job, because he actually went around and talked to a lot of you guys and make this actually possible. Good. I'm done. Are there any questions?
So we have some time for some questions for Claudio. No. Okay, well, please join me in thanking Claudio for a very interesting presentation. Thank you.